Okay, so managed to turn the audio on. Can you hear me now?
Yes, I can hear you. Sorry about that.
Okay, well, I kind of scrolled through this mainly for reference, but some of you have presentations already graded and demonstration already graded. So, and then you kind of see the add to it. So the maximum right now would be something like that. But I wanted to kind of give people an idea of where we are. Um, like I said, quite a lot of points. I said it, but it was muted. Quite a lot of points still out there. Um, so today we're covering lecture 7, which is about visualization of hierarchies. So we already started, but now we're covering a few more of those. And that would be right here under lecture 7. Here's the lecture, and then some of these are videos, other are actual tools that in theory you could download and run and see how they work. Uh, this will come into effect, probably going to be useful, more useful today. I'll talk more about it. And as far as quizzes go, let me switch the mode. Let's look at this last quiz. So edge bundling, it tries to find a way to route edges so they don't. It almost looks like how blood vessels are routing through our system. So if we go from point A to point B, we have smaller blood vessels combined into bigger one, and then they kind of get routed all around. And it just reduces the degree of intersection. So it's a interesting technology where instead of an edge going straight from point A to point B, it might actually get combined with other edges, and they form a big bundle, and it kind of reduce intersection. But they do reduce intersection, but they generally end up creating a lot of bends. The variation of length, it's going to be whatever it was. I don't think it makes it any worse or better than before, but it definitely tends to bend the links. So and here is some of transitioning from graphs to trees. And I was telling you in the lecture that a tree is just a graph, a mathematical graph that has two properties. They're all connected. In other words, I can travel from each node of the graph to any other node, and there are no cycles. So it has enough edges in there to connect all the nodes, but not too many edges to create cycles. So that's going to be a tree. Now, when we're building a graph visualization, I know we have to do this 1, 2, and 3. We already kind of covered in homework 4 and talked about it already. But there's no level involved for graphs. So that's something that comes up with trees. And a pure tree, in its mathematical definition, that's what I mean by pure, by just the bare mathematical definition of a tree. There is no idea of a hierarchy level or anything like that. We start to have hierarchies and levels once we pick out a root for the tree, and after that, we kind of start to come up with levels. Okay, so again, same idea. A tree that has 227 nodes has how many edges? It's always going to be -1, so it should be 227. And then I mistyped. And then a tree with 229 nodes is going to have 228 edges. If it has one more, it's going to be too many. one too many. If it has fewer, then some of those nodes won't be connected to others. And if we stretch out graphs, so that idea is, there was a picture in the slides that showed kind of attacks from Britons to Northumbria, from Scots to Britons, and so forth over time. So instead of having one single graph that showed Britons attacking, all the attacks who attacked who over time, what they did, they stretched out the graph. So they repeated the same node, like Britons were repeated multiple times, and Northumbria was repeated multiple times, and so forth. So what that does, it just reduces intersection. It eliminates intersection. There is no intersection in that one. We're using a little bit more space because we're repeating nodes, but we make sure they don't intersect. Edges don't need to be bent. They're always straight. And then the variation can happen. So we can have some of these that are, some edges that are longer than other edges. Okay, and this last question is about upset. And upset, we were moving into relationships that are not binary anymore, because a graph is a binary relationship, but an edge has, two ends, and that's it. But then what happens if we have relationships that are not that include multiple things, like meetings? People in a meeting, it's not like they meet each other one-to-one. It's like everybody is in there. If I have a meeting with 20 people, all 20 people are in a relationship right there. So imagine an edge that's no longer binary. And we're starting to talk about sets, visualization of sets. And that's a very tough thing to do most of the time. But this upset view that I found, it does a pretty good job. So, and basically what this question asks is, if I want to show the entire set A, that's interesting. No, I'm still confused on my monitor. Sorry. I need to put a large black circle on A, but what that black circle does, it shows only A, so no intersection between A and B or between A and C. And if I want to show those, I need to put small circle on B and a small circle on C. And now I'm seeing the entire set A. So basically, in other words, this set is composed of elements that belong only to A, which is the large black circle. And I will have to click on it, basically, to turn it on. And then plus the things that belong to A and B, and I need to do something on B like that, and things that belong to A and C together. So the intersection, set intersection. And let's see if I got it right. Oh, I read that incorrectly. Okay, so I need to go back to it. And that question I'll do it again. Okay, so now it's changed to number 3, but it's this one can be easily satisfied. I think these two are the right thing. So the variation definitely reduced link building. They're always straight. I said it, but I didn't click on it. And that's the right answer. Okay. So that was the quiz. And next, let's talk about, I have the next and last homework out. And here we're going to look at trees. We're going to use tree map. And I'm kind of, let's see, what it should be under the pre-recorded stuff. I'm not going to repeat it necessarily, but well, it's not. Okay, it means it's missing. I'm going to add it there. I have a, or maybe it's in the previous. If not, it's possible I did not. No, none of them. It's not in there. I have a pre-recorded session kind of showing you that not all tree maps are the same. And I think I copied, when I copied the course shell, I copied from 2 semesters ago, but I think I might have introduced that last semester. So that needs to be added. So I will add it there to basically April 7th, so you kind of get an idea. But I was thinking that all tree maps are tree maps, but then if I go to the original tree map that the original creators from University of Maryland, there were a group of researchers there that created it, and actually they were pretty good at promoting it. But their original tree map, it turns out, works completely different than what you would find in something like Power BI. And it's kind of hard for me to compare everything, but it was an interesting thing that they don't work the same way. The visualizations, the way that you create them, in a nutshell, it's almost like the difference between a parallel coordinate plot, which focuses more on attributes or properties, columns, versus a star plot or a radar chart, which focuses more on objects, on rows of a tree. It's not quite exactly the same thing, but it's very close to that analogy. So some tree map software focuses more on the property of the data set, on the columns. Others, like the original one, focus more on the rows. And there may be other variations. So be very careful. They look the same, but they're not the same. So that's kind of how I got the idea for the homework. And the other thing that I don't like about this homework is that this original tree map software is kind of old. So I don't want people to really install them on their computers. So I recommend, and I put it even here, I recommend that that you use the virtual lab for this one, because over there you can just download it, log on to your Blackboard, and download it there, and don't have to worry about other stuff. And I'll make sure it works right now. But here, so that's kind of the first. So this homework has 2 parts, and for this, give you more points. We'll start at 7. So the first part is kind of worth 3, and the second part is worth 4, if that matters. But the first part, it focuses on the original tree map. It's going to be a little bit more technical. And then the second part is up to you. Pick a different software to build a tree map and see kind of how that works. And then compare the two. Compare, just put them in. For this, just again, I needed some data set to look at and the question, and I kind of posted it here. So first of all, these are some aircraft incidents. And let's see where this will pop up. Yeah, popped up on the right thing. So if you look at this data set, it doesn't look like a tree data set. And that's kind of, if you want to think about the project and alternatives for the project, here is a data set that has no tree structure or anything like that, but we can use a tree map to look at it. So we can take some data and just think of it as being in a tree structure. And that's basically, demonstrate some of it in a second. But it's a lot more in the pre-recorded lectures that will have it. Not about this data set, but in general, how a data set that just has normal rows and columns can be viewed as a tree, and even as a graph, if you just think of it in that, and even or a set structure like upset visualization tool, the one that I talked about today for the quiz. Okay, so that's the data set. Seems to be okay. And here we're looking at whether there are different. So from this data set, really, I put it all in there, but really there's only 3 columns of interest. One is ops code, the other is deadly injuries, the other is not injured. So basically the question is, use tree map and this data set and try and, of course, as always, like from the first homework, if you need to derive a new column from this, derive it if you think it'll help. But the question is, if we look at the different operations of flights, are there some that are similar to each other? Some of them have, I don't know exactly right now, but some of them have 800 instances, others have maybe just 80. So the number of flights or the accidents are different, but in terms of the proportions of deadly injuries versus not injured, do they look the same? So can I build 1 or 2 or 3 views that will help me answer this question? And again, from the data set, the thing that matters is the ops code. So that's the ops code right here. And there's about 1,200 rows in here. Deadly injuries is another one that matters. And then not injured. So a lot of these accidents or incidents will end up with almost no injuries and no deaths. Just, broken parts, broken airplane parts or aircraft. So these are the 3 things. Do you want to keep the rest in your data? I leave that up to you. I know what I would do if it were me, but really the question only asks about deadly injuries, not injured, and opcode. Everything else, it's not part of the question. Okay, so then what I'm asking you to do is kind of use the original tree map. If you need it, it's going to be under lecture slides, lecture 8. There's a zip with the original, and it pretty much should run after you unzip it. It should be able to run. So it's this one here. And like I said, I also suggest use a Porto virtual lab so you don't have to worry about installing Java or not. So I want to make sure it works too. Last time I tried it, it worked, but it was at the beginning of the semester. So that's just a computer, and I think you have administrator privileges. You can install anything you want on that. And obviously I can allow that. And in here, if you ever wanted to play with, I think Power BI used to work in here. I know I tried Tableau and it didn't work, so I wouldn't try it. But Power BI is already installed if you ever want to not bother about installing it and try it for a few minutes. So here, there's ways to upload and download from this. And I already have the zip file right here. And then be very careful, though, if you go to this folder and you go to your, if you take a screenshot or something, make sure, because it tends to put the username there. And you know, I want this anonymous, so make sure the username does not show up in there. But that's kind of one place it will show up from time to time. It kind of, I noticed it in the past when people use a portal. But other than that, you can just use snip, I think, sorry. If you ever need to take a screenshot from this, and it can be downloaded and uploaded and so forth. So on this PC, I know I have it somewhere. Not here. Documents. Not even here. Let's see, maybe it's under downloads. Somewhere I already unzipped that file. So I unzipped it under downloads. You can see here I plugged it in, and here's the folder. It's just a normal straight unzip. And if I'm lucky, it should run. Just, you can click on either run or tree map. And I need to agree with this. And it starts up by telling you to select one of these documents. Notice that as far as tree map is concerned, there are two types of documents. One is a TM3, which is the data itself. And this is a TMS. It's really just one view. And so you would have to produce the TM3, and then it can be opened. So for example, I can open here, election, no hierarchy. And by the way, I'll open it up and I'll explain what the hierarchy, before I go any further, actually. No, I opened it up, and it kind of looks something like this. Here is kind of an overview of the data. I could try, I'll open it up in, they have sample data sets. So it was election, no hierarchy. One thing that would mess you up, and apparently it messes it up right now, and I'm going to record this. Notice that the TMS file doesn't show up an extension. The TM3 does show up an extension. And I think I created it here. So I took this and I made a, basically this is a tab file. So if I take this and copy, I made a copy of it and I changed this extension to txt. Then opening it up, you kind of see it's a text document, nothing more, nothing less. It's a tab separated. You heard of comma separated CSV files. This is a tab separated. So it's a TSV file, really. Let me see if that will trigger.
So was it originally a TSM file?
TM3. Tree map TM3, probably the third version. But it's really tab separated, and that's the hierarchy, state, country, region, who won this election, and so forth, population. And so it does look, and then we have each and every state in here with the right numbers. Glad there's a new version of Java. And that's the nice thing about the portal app. I don't have to worry about updates or anything like that. They take care of it. But that's what data we're looking at. And if I pull up tree map again, here is the data kind of for that. For this particular tree map tree. The nice thing about tree map and most visualization software is that most tree map software, it allows us to do a, I need to make this a little bit larger. Allows to do, and it's still not large enough. I had a trick on how to do this. Create a hierarchy. And for example, one hierarchy is break down the states. And it normally shows up here, but the resolution of this machine is really low. See if there's a way to make it full screen. And I'm not sure if I got, oh, I need to make this full screen. And now it's a little bit, you can kind of see the hierarchy showing up. So the default hierarchy means nothing. It just shows each and every row from that data. And that's kind of the difference from Power BI would not show each and every row. They kind of show each and every column of the data set. They're focused on that. But I can introduce a hierarchy. And here, click new. That's not it. Oh, I need to select a row. So for example, if I want to break it down by region, I can add. And notice that these are the regions: Northeast, Rockies, West, Midwest, Central, Far. So these are, and then each state is grouped by region. This is a dynamic hierarchy. If I want to kind of break it down some more into the party who won in 2000, you can see the West, mostly Democrat and a few Republican, can kind of see how that breaks down. So now the hierarchy is that this is my root, and then it's broken down by region. And then in each region, I can see the party that won in 2000. So that's what they mean by dynamic hierarchy. It's possible to even put values there. So, or I can go ahead and remove the region from the hierarchy. So now it's Republican and Democrat as each state. And very quickly, I could go something that is the number of votes, for example, for Bush. And I can say I want equally dense bins, and I want 3 of them. And hit add. So you see the Democrats now, they're split into 3 bins. So even, I guess what I'm pointing out, and again, that's probably important for the project, even things that look numerical can be used to break down into hierarchies. So this is the number of votes that were cast for Republicans in these 3 type of bins, and that's for Democrats. And they're equally dense, so you expect them to be about the same size. But that is the hierarchy feature. The other feature, any tree map, they have labels. So I can change label on based on the number of electoral votes. That it's not as good for a label, and might as well just I can label it by the party who won in '92. And the size can be based on the number of electoral votes. And now you start to see, and let me go back to the label and put the state. I think state is the most common label. So obviously California has the most electoral votes, or had at that time. It probably still does. But I can check that. And then here it makes sense to basically color it based on the party. And Democrats, blue are good. Republicans, I can pick something more red. And we can see some differences right now. So it looks like Democrats held whatever they did, because this is broken down by party. I can't remember what I put in the hierarchy, but I can look party in 2000. No, Bush votes, probably the last election in this data set. So that's what this bin does. Let's take it out completely. So we can see that Democrats won some state at some point, and then Republicans didn't really win much. Based on party in 92, then party in 96. Again, let me pick something red. And then if 2000 should be the current version, so that's kind of what we see. Now they're nicely split between Democrat and Republican. I mean, all the Republican one are red in this side, all the Democrat one. I kind of grouped them. In other words, I grouped them together. So if you really want to group something, just make sure your hierarchy and your color kind of are the same. I can explore the data set, but that's not the point. So for the homework, what I'm asking to do is go here and basically save settings. And I can save this TMS file, give it a name, and save it. And that TMS file now holds all the input, all this view. It basically remembers how to create this view. Okay, so I stopped it. I'm gonna show you a little bit how that looks like. So that's what I created here. I'm gonna edit with Notepad so we can look at it. But this is a TMS file. You can kind of see the extension right here. Right here. But as you can see, it just remembers all my choices. It doesn't really have data inside of it. It remembers where I got the data from, the file name for it, treemap, or that's the title, but somewhere in there is the data set. I think it's the second row. Base says it's using this file. So the way this works, it kind of splits the data from the view. So this is the view of the data, the TMS, and then the TM3 file is the actual data without any, just plain raw data, no view on it. One thing, if it gets annoying here, and I know people are not going to find it necessarily easily because it's in the middle of this, but one thing we can do is search for folder options or file explorer options. And under view, deselect hide extension for known file types. So if you deselect this one, then the extension is going to be shown for all files. So that makes it easier to see the TMS files and their extension, or any other extension. So even the TXT file shows up the same way. Okay. So when you're done, you can probably submit it from here or download it to your own computer. Take a snapshot, save it, and let me kind of go back to the homework. So everything I was demonstrating and explaining is what I would like you to do. So first of all, you need to, I'll get to the modification in a second, but as you open TreeMap and open the file that you processed, just every time you see some, go through that process, select the hierarchy, select the legend. In the legend tab, here is the legend tab. I don't have it running anymore, but I'll start TreeMap again. It didn't like me this time. And I will open this one, April 2025. And that will take me exactly where I left off. So if this is something I would like to demonstrate, take a snapshot, save the TMS. So do these two things, because I'm asking, you need a snapshot for the normal homework submission document, but I also want you to send me the TMS files for every snapshot that you have in there. And then, oh, I was talking about legend. Legend tab is this one here. It shows what the label is, size, and color. And I'm asking every time you take a snapshot, please, please, please make sure the legend tab is selected here. Legend tab is visible when you take a snapshot. And let's see. Here is kind of where it can catch you, but make sure you do a snip. Do not add. I don't have a better way. I'm sorry. I apologize, but do make sure it doesn't capture this part, because you can see your user right here. So with the snipping tool, just hit new and select the part that needs. I stopped too early. Okay, new one. And select this and then let go. So basically now, well, I didn't. I need to click again apparently. And then in here, notice that I did not capture my name in there. So be careful with that. That's kind of the annoying part, that I don't like this, because it's easy to capture, but make sure the legend is visible. And then take this, put it in your document. So this, the snipping tool will also allow you to save it as a file either way. And I think there's Word on this computer no matter what. So that can, I'm not sure. Let me try. Oh, probably because there's Office. So you can create your document right here if you needed to, and save it as a PDF, or just take the files, save it as a JPEG, and then add it on your own computer at home for this one. But that's kind of how I recommend doing that. Be very careful with capturing that part. Now, there's a way to not be there. Put it on the, I'm not sure where the desktop is. It may not be that great either. Let me try it on the desktop. If so, I can recommend that. So let's see what happens if I start it from the desktop. It still shows up. So there's no good way other than be careful not to capture this top part. Oh, by the way, you can do a snapshot of this from your own computer. It doesn't have to be in a portal. So I can do it from this machine here. That's probably easier. So this way you don't have to, but at some point you still have to transfer data to and from, upload and download to the Portal Virtual Lab. Okay, so file, save settings. That's kind of where make sure that Legend tab is visible. I put it, in bold. And then what I like to do is zip all the TMS files and the TM3 files. Sometimes the TXT works as well. If it's saved as a TXT, it's not going to give an error. And I will ask you to submit this zip file and the final document together. And then the second part, one more before I move any further. Here is where I haven't talked much about the Excel file that I gave you, which is this one, would need to be modified. So the documentation is in lecture 7. Let me pull it up quickly. And it pulled up on this other monitor. So here, when we talk about tree map, there's a link for the documentation. It's slide 22. I'm just going to copy it and go to it. And right here, create your own data file. It explains how this data file is to be created. So the thing that, there may be two things that you need to take care of. One is add this second row. And they only accept 4 data types: float, integer, date, or string. So it's not that complicated. Obviously, the type of operation is going to be string, and then the other ones, the number of injuries, are going to be integers. So these are the only two that you have to really deal with. But you have to insert this second row in Excel. So open that Excel file. That's why I even give it in Excel. So right here, it doesn't, I'm not enabled editing. So right here, I need to add that. And I need to, the ops code, like I said, it's string, just like they have it in there, capitalized. And then this is going to be integer, just like they have it in the documentation here. Okay, so that second row needs to be added. Don't worry about this, is adding a hierarchy to it, kind of a hard-coded hierarchy. We don't have to do that. We're kind of using a simplified format to use with flexible hierarchy. And that I started showing, that's kind of all I did. So we don't have to add anything other than number 2, then the second row. There's no need to add more stuff here. No need. So don't add that stuff, the hierarchy. What they're doing here, they're adding a hierarchy, and I'm not even going to talk about it anymore because we don't have to do it. So that's where the documentation is. Prepare that TM3 file, save it from within Excel, save it as, and again, all these are going to be in here. And save it as a tab delimited text file. Like I said, if you could rename it to TM3, but actually the software TreeMap would not going to complain if it's a TXT. It's going to be happy to open it, even if it's a TXT, as long as that second row is there. And I think that's all I have about this first part. And then for the second part, use a software of your own choosing. I doubt we would have, here I'm just trying to convey the fact that it'll be interesting to see if you can have a view from that other software that shows maybe something like this, what the size, color, label hierarchy. As much as that is, it's obvious for people to understand what they're looking at. Not all pieces of software do that, and they definitely don't do it exactly like TreeMap. So this is kind of a wish list, more or less. See if you can replicate. It may not be possible. And so create your answer document. Specify which software or website was used. There's some things that work on a website and create tree maps. Searching on the internet should give you lots of options for that. And again, the only thing I hate about this assignment is that tree map is old, the original one. But not all tree maps, you will see that not all of them are equal. They're going to create different views for the same data set. And it's impossible to almost replicate them from one to the other. And so turn that in, turn the answer document. I guess I didn't put that, but turn the answer document. I'll change this quickly when I get it. At the end of class, I'll make sure I add a I'll add another point here just to make clear that you need to turn in the document. Just like normal, a PDF or a Word or a PowerPoint or something that can be easily opened and looked at. And then the zip file as well.
This will be due next month.
Yes, it's due in 1 week. And after that, we'll do the normal review. Here are the criteria. I figured this time, so starting at 4, so if somebody didn't use the original TreeMap software, then you can deduct. I put a subtract 3 points, so it made it easier to not lose many points. So if they only use TreeMap, they subtract 3 points, and then everything else is right there. The other, we'll talk more next week. I already talked too much today about this homework. But when we talk about review, that's kind of give you an idea where we are. Okay, I will do 2 things, and it's on my to-do. I'll do it right at the end of class. I will add another point here just to make it clear. Well, it's pretty clear here because it says turn in the answer document and the zip file, but I'll add one more point here. So I need 2 things. For this one, you need to upload 2 things. One is normal document answer, and one is the zip files. Zip file with a TMS and a TM3. Okay, so any questions? I talked quite a lot, put a lot of information out there about this homework. This is the most technical one for those of you who avoided some, but it's mostly point and click and using Excel and changing file names. Kind of keep making progress on the project. I'll keep on going here. We're going to have in about 2 weeks and by the way, in about 2 weeks, this homework will be done and we're not going to have any more homework. I mean, the homework is due next week, but the review will take another week. So by April 21st, we'll be completely done with all the homework. You will be completely done with all the homework. I still need to grade it. But progress report is coming up. It's going to be April 21st, 23rd. This table that I'm here, it's too small. I need kind of to expand. So it'll be virtual only. I kind of tell you right now, no in person for that. Plus, it's kind of, not a lot of people show up in class, but if I have them, it's hard to manage laptops being exchanged. It's a lot easier to just share your screen on Blackboard. So that's coming up. Demonstration of visualizations tool still going on. So I think I had almost all the teams submit, and we have 2 more teams for April 14th. So we'll be done with demonstration of visualization tools next week with all of them. Most of you should already be done. And I'll start talking about recap, but in about a week or so. It's coming up, but it's going to be the end of the semester. Okay, I think I'm done with this. Trying to find